multiplying radicals with polynomials. What we're going to be doing in this section is doing the distributive property and the FOIL method, but with square roots. I'm only going to do square roots. Now, in order to multiply, they have to be the same root. So on the previous lecture, I did multiplication. Now, I'm going to apply that to polynomials. Now, let's start out with, let's say I had the square root of 7 times square root of 3 plus 5. Doing the distributive property, just like we normally do. Multiply the square root of 7 times the square root of 3, and you'll get square root of 21. Square root of 7 times a whole number 5. The 5 is not under the square root symbol, so it goes in front, and you put square root of 7 behind it. So you multiply what's underneath the square roots. If a number is not in front of the square root, it goes in front. All right. Suppose I had 2 square root of 6 times 3 square root of, let's do 7, I guess, minus 4 square root of 11. Now, we're doing the distributive property. Now, notice there's numbers in front. We multiply those together. Then we multiply the numbers underneath. Same thing. Multiply the numbers in front. Then multiply what's underneath. This is my answer. That's all I can do. Sometimes you may be able to simplify once you do that, and I'll show you some of those. But the whole thing is to do the distributive property. Here's one we'll have to simplify. So let's say I had 4 square root of 8 times 3 square root of 5 plus square root of, I don't know, we'll say 10. Well, distribute the 4 times the 3, 12, square root of 8 times 5 is square root of 40, plus 4 goes in front, square root of 80. Now, we've got to try to simplify what's underneath. Now, remember, I can write 40 as 4 times 10. Take the square root of the 4, which is 2. Then we multiply the 2 and the 2 and the 12, we get 24 square root of 10. Now, I got to try to see if I can do 80. So if I list out all the factors of 80, let's just do 80 and see what comes out. Now, I'm looking for the biggest perfect square. 2 and 40, 3 doesn't go in there, 4 and 20, 5 and 16, 8 and 10. So which one is the biggest perfect square? Well, 16. So I can rewrite this as 4 times 16 times 5. Square root of 16 is 4. And 4 times 4 is 16. Square root of 5. Now, that's all I can do. That is the answer. There's nothing else I can do. Stop. Now, sometimes you might have a variable. Let's say I had, I don't know, square root of x times square root of 6x plus 2 square root of 7. doing the distributive property. And if we can, we're going to simplify at the end. All right, so we're going to have the square root of 6x squared plus 2 times the square root of 7x. Multiply what's in underneath the radical sign. Now look here. I got an x squared. The square root of x squared, remember, is x. And we got a square root of 6. And then we've got 2 times square root of 7x. That's my answer. Now, doing the FOIL method. We're going to be multiplying roots together. Doing the FOIL method. It works exactly like the normal FOIL method. I'm going to write it out the long way. You take the 2x, you take the square root of 2x. The square root of 2, and you multiply it by what's in the second parenthesis. I'm going to highlight the second parenthesis. So this is going to be the second parenthesis. This is the, this is the, from the first parenthesis. All right, so we're going to have 4 square root of 2 minus 6 square root of 3. Then we're going to take the square root of 3. And we're going to take, second parentheses. Do it in yellow just to make sure we're seeing what I'm doing. So we're going to have 4 square root of 2 minus 6 square root of 3. So we're multiplying everything in the first parentheses by square root of 2. So let's do that. So square root of 2 times 4 square root of 2 is 4 square root of 4. Square root of 2 times negative 6 square root of 3 is negative 6 square root of 6. And we've got square root of 3 times 4 square root of 2 would be 4 square root of 6. Square root of 3 times minus 6 is negative 18 square root of 9. We're going to go simplify this and add like terms. I can take the square root of 4, which is 2, and I end up with 8. These are like terms. Minus 2 square root of 6. This is a, well, let me take away that plus sign. This is negative 18 times 3, which is negative, what was that, 54. Now, I can combine the constants. There's a lot of adding stuff here. Minus 46. This is the answer. All we can do. All right, let's say we had, I don't know, we'll do 2 square root of x minus 4 square root of 11 times, I don't know, 6 square root of x plus 5 square root of 11. I'm going to use the arrows this time, but we're doing the same. I'll highlight it. I'm going to do it. So we're going to do pink. Whoops. I'm going to erase that. So highlight. I'm taking this piece times everything in the second parentheses. So times 6 is 12. Square root of x times square root of x is square root of x squared. 2 square root of x times 5 square root of 11 is 10 square root of 11x. Now, we're going to take the minus 4 square root of 11, multiply it by everything in the second parentheses. So we'll get minus 24 square root of 11x minus 20 square root of 121. Go through and simplify. I can simplify square root of x squared, which is just 12. Whoops, it's 12x. These are like terms, so we can add those together. So we'll get minus 14 square root of 11x. I can simplify that. It's negative 20 times 11. And 20 times 11 is negative 220. Now, I can't do anything else on this one. This is the final answer. There's nothing else I can combine. So what am I doing any different than we've done in the past? Nothing. We're just doing the FOIL method, but we're working with radicals. There is nothing harder on the final than either one of these two problems. I promise. So, you're just going through the FOIL method. FOIL method, FOIL method, FOIL method. Alright, so try to do the homework. If there's something on the homework that I didn't do, let me know and I'll go over it. But I'm pretty sure it's just straightforward multiplication and adding like terms, simplifying roots.